Okay, so let's see if I can show you guys how we would derive the law of cosines. It's kind of fun, actually. Now, I wouldn't necessarily expect you to be able to do this on a test, but if you're working collaboratively, I would expect you to be able to talk to each other and be like, what could we do next? And then just kind of be able to work it out. So let's go to the next slide, and I'll show you how we begin. Okay, so let's start with this triangle ABC, and just so you know, when we have a triangle, or any kind of polygon really, in geometry, usually we're going to label it with capital letters. So the vertices, like capital A, capital B, capital C. And then the sides, we're going to label the sides the same letter as the vertice, but the lowercase. So the side opposite vertex A is going to be lowercase a. The side opposite vertex B is going to be lowercase b, and the side opposite vertex C is going to be lowercase c. All right, so now to derive the law of cosines. This is so much fun. Now, you're not going to have to do this all the time, because once you have the law of cosines, then you just use it. But sometimes it's kind of just fun to know, where it came from. You already have the law of sines, and the law of sines is if you do not have a right triangle, and you happen to know an angle measure and its opposite side length, and then one other measurement, and then you could find the rest of the triangle. In this case, if we're looking at the law of cosines, we're going to assume that we have side A, side B, and angle C. So that's what we're going to assume. It's kind of like if we have side, angle, side. So if I've got a side length, and the angle in between, that's when we're going to be able to use the law of cosines. So to start this, I am going to draw a line from vertex V to break this big triangle into two small right triangles. Okay? And let's label the length from C to where this line comes down. Let's label that X. And so let's label the height Y. And then in the triangle on the right, let's label that bottom length B minus X, because this whole length is B and this part's X, so what's left has to be B minus the X, okay? All right, so let's start. Basically, I'm going to just keep using Pythagorean Theorem for the most part. So if I look in the small triangle, I know that X squared plus y squared equals a squared, just using the Pythagorean theorem. The other thing we know from that triangle is, since we are going to assume that we know theta, or angle C, we're going to say that the cosine of angle C, I'm just going to call it a C for now, is equal to the adjacent, which is x, over a. Okay, so that's what we know so far. And then in the other triangle, it's kind of the same thing, but it looks a little bit more complicated. I know that I've got y squared plus b minus x, the quantity squared, and that's got to equal c squared. Okay, so to start this off, we're just going to do some math. We're going to simplify stuff. So I need to multiply out b minus x squared, and that's going to be b squared minus 2xb plus x squared. And you could just use FOIL if you want. You can use a generic rectangle, however you want to multiply that out. I still have this y squared here, and then that all equals c squared. So all I did was multiply the b minus x squared. So now what we want to do is I want to substitute equal values so that I can get rid of all the x's and y's in that last equation. So I'm looking at this equation here, and I want to derive a formula to find c, but I want to get rid of my x's and y's. And so what I'm going to do first is, I know up above here, so using this top equation, I can say that y squared equals a squared minus x squared. So down below here, I'm going to say y squared is a squared minus x squared. I'm still going to rewrite the b squared minus 2. And then instead of x, in this formula up here, I've got an x there, but I can rearrange it. So I'm going to rearrange that so that x equals a times the cosine of c. So right here, instead of x, I'm going to put a times the cosine of c. And then I've got a times b, see that there? And then plus x squared equals c squared. Doesn't that just look so fun? It's like all this stuff and we're going to make it one formula. All right, so if looking through that now, look, I've got a minus x squared, I've got a plus x squared. They cancel out. They're out of here. And then I'm just going to clean it up a bit. And then we've got the law of cosines. So here we go. We know that, here, let's make it a different color. Let's make it blue. All right, so I've got a squared plus b squared minus 2a, and I'm just going to put that b over here, b times the cosine of c, all that equals c squared. So, ladies and gentlemen, this right here is the law of cosines, okay? So basically we just used the Pythagorean Theorem twice. I did need to use cosine, and we just kind of substituted equal values in there so that I could have a nice looking ABC formula, okay? So the capital C is the angle, so right here, this is always the angle of C, and so that's when I'm trying to find the side opposite of C. So if I want to find the side opposite of C, I need to know angle C, and I need to know the two sides that make it up, okay? It doesn't have to be a C, it could be A. So if I was trying to find side A, I would need to know angle A, and then I would need to know the other two sides. So there is the derivation of law of cosines.